Imagine you hire a research assistant. You give them a topic, say, the impact of AI on the job market and healthcare, and you ask for a thorough, well-written report. A bad research assistant does everything at once. They open a browser, skim a few articles, start writing, go back to search for more, revise mid-sentence, forget what they already know, and hand you something that's technically a mix of research and opinion with no clear structure. A great research assistant works differently. They gather first, then they evaluate what they gathered. Then they synthesize it into a coherent narrative. Then they format that narrative for the specific audience and purpose. 4 distinct phases, and every professional knowledge worker, journalist, analyst, consultant, academic, works this way. Not because they were trained to, because complex information problems have a natural structure, and the best workers learn to work with that structure instead of fighting it. This 4-phase pattern, gather, filter, synthesize, format, is the single most reusable pipeline structure in AI-assisted work. Master it, and you have a template you can deploy across almost any research, writing, or analysis problem. This lesson is about understanding that pattern deeply, not just what the stages do, but why they exist, what makes each stage work well, and how the stages connect into a coherent system. Let's start at the very beginning of the pipeline, the gather stage. Think about how a gold prospector worked. They didn't pan every grain of gravel by hand from a standing start. They started by going to the right river, doing high-level research on where gold was most likely to be found. Then they scooped large amounts of material. Then they sifted. Then they panned. Then they refined. The gather stage is the scoop. It's the wide net. In this stage, the job of the AI is to retrieve, surface, and capture as much potentially relevant information as possible about the topic. The prompt is deliberately expansive. You're not asking for the best 5 points. You're asking for everything that might be useful. Why deliberately wide? Because premature filtering kills relevance. If the gather stage is too selective, it discards material that would have been valuable context for synthesis. Better to capture too much and filter it down than to lose something important before you ever see it. A good gather prompt might look like, you are a research assistant. I'm researching topic. Generate a comprehensive list of key facts, trends, debates, relevant statistics, important actors, and open questions in this space. Be thorough. Prioritize breadth. Don't evaluate or filter yet. Just capture everything that might be relevant. Notice the explicit instruction not to evaluate or filter yet. This is deliberate. You're telling the model to stay in one cognitive mode, retrieval and capture, and not to prematurely jump into analytical mode. The gather stage output is typically a structured list, a wide collection of points, facts, perspectives, and questions. It's intentionally messy. There will be redundancy. There will be tangents. That's fine. The mess gets resolved in the next stage. The second stage is filter. This is where critical judgment enters. The filter stage receives the wide collection from gather and applies analytical criteria to separate what matters from what doesn't. The output is a curated, tighter set of information, the material that is genuinely relevant to the specific question you're trying to answer. This is where you stop treating all information equally. A filter prompt might look like, you have received a broad research collection on topic. Your task is to evaluate each item and select only the ones that are directly relevant to this specific question. Exclude anything that is tangential, redundant, or that doesn't contribute meaningfully to answering the question. Return only the selected items in a numbered list. The key discipline in the filter stage is having a clear filtering criterion, a specific question or objective that the filter is applied against. Without a specific criterion, the model defaults to generic relevance judgments that may not serve your actual goal. Be precise about what you're filtering for, not just filtering away from. Notice that the filter stage also serves a second function, compression. You're reducing the volume of information that flows into the synthesis stage. This matters enormously because the synthesize stage needs to reason coherently across everything it receives. Less is more here. provided the compression preserves the right material. The third stage is synthesize, and this is where the actual thinking happens. Synthesis isn't summarization. This is a common confusion that leads to weak pipelines. Summarization condenses information. It makes long things shorter while preserving the original claims. Synthesis constructs something new. It takes multiple inputs, finds relationships between them, identifies a coherent pattern or argument, and produces analysis that couldn't exist from any single input alone. A synthesis prompt reflects this distinction. You have received a curated set of research findings on topic. Your task is not to summarize each point individually, but to reason across all of them. Identify the underlying themes, surface the tensions and contradictions, build a coherent analytical perspective that addresses specific question. Your output should be a structured analytical narrative, not a list. When the synthesis stage works well, you feel it. The output isn't a reshuffled version of the inputs. It has reasoning. It makes connections. It reveals something that wasn't obvious from any single piece of information. The fourth and final stage is format. This is often underestimated. People treat it as just making things look nice. But format is where the content transforms from analytical output into audience-appropriate communication. A format prompt might specify, take the following analytical narrative and transform it into a professional blog post suitable for a senior healthcare executive audience. Use active, direct language. Structure it with a compelling open, 3 main insights with supporting evidence, and a closing recommendation. Maximum 800 words. 4 stages, each with a different cognitive job, each designed to build on the precision of what came before. That's the gather, filter, synthesize, format pipeline, and it's as powerful in practice as it sounds in theory.
Now you know the architecture, but knowing that stages should have clear I/O contracts is one thing. Knowing how to actually prompt for consistent, predictable formatting across those stages is quite another. This is one of the most practically tricky parts of pipeline engineering. Here's a scenario that plays out constantly in real pipeline work. You build a 4-stage pipeline. Stages 1 through 3 work beautifully in testing, but every time you run it end-to-end, stage 4 produces slightly different formatting. Sometimes it uses headers, sometimes it doesn't. Sometimes it adds a subtitle. Sometimes the bullet points come first, sometimes a paragraph does. The content is correct, but the format varies enough to cause problems in whatever system or presentation you're feeding it into. The content is great, but the system downstream expects clean, predictable structure, and now you're manually editing every output. The root cause is almost always the same. The format specification wasn't explicit enough, specific enough, or placed correctly in the prompt. Here's the principle. Format instructions should be the last thing in your prompt, not the first. This sounds counterintuitive. You might want to put the format requirements up front so the model knows what you want. But in practice, models tend to interpret format instructions better when they come at the end. The model processes the full instruction set, forms its understanding of the task, and then, as the final constraint layer, applies the formatting specification to its output. The right structure for a format-sensitive prompt is context and role, task description, input data or content, output format specification. The format specification at the end acts as a mold that the model pours its completed reasoning into. When format instructions come at the beginning, they can compete with the task instructions for attention, leading to the model weighting format over substance when it should be weighting substance first. Now, for the format specification itself, the rule is be specific enough that there is only one valid interpretation. Write it clearly is not a format specification. It's a preference. Format your response as a JSON object with exactly 3 keys: title, a string, summary, a string of 2 to 4 sentences, and key points, an array of exactly 5 strings. That is a format specification. There's only one valid way to interpret it. The more structured and specific you are, the more consistently the model performs across runs. This is especially important in pipelines, where inconsistent formatting in one stage can break the parsing logic in the next. Here's a technique that experienced practitioners use. Include a format example in the prompt alongside the format specification. Not just return JSON like this format, but here is exactly one example of a valid output for this stage. One concrete example is worth more than 3 paragraphs of description.
So how do you manage context accumulation in practice? There are 4 core strategies, and they work together. The first strategy is selective context passing. Each stage receives only what it needs to do its specific job, not the complete output of every previous stage. This sounds simple, but it requires deliberate design. Before you wire up your stages, ask, what is the minimum information Stage 4 actually needs to do its job? Does it need to see Stage 1's raw research collection? Or just Stage 3's synthesized analysis? In most pipelines, later stages need only the output of the immediately preceding stage, not the full history of how that output was produced. Design your stage connections to pass the output, not the history. This single discipline, passing only what's needed, can reduce context size by 60 to 80% in a 6-stage pipeline. And smaller context means cleaner focus, lower cost, and faster execution. The second strategy is intermediate compression. After certain stages, add an explicit compression step. Compress the following content by removing all redundancy, preamble, and metadata. Retain only the core information in the most concise form possible. Output must be under X words. This compression step costs 1 additional AI call, but it pays dividends across every subsequent stage. Think of it like defragmenting a disk, a small, one-time cost that makes everything after it run more cleanly. The third strategy is indexed references. In long research pipelines, instead of pasting the full content of a source document into each stage, you create a document index at the start of the pipeline. Each source document gets an index number. Then, in subsequent stages, instead of carrying the full documents forward, you carry only the index and reference documents by number. A stage prompt might say, analyze the findings from documents 2, 5, and 7 in the document index. You do not need to process the other documents. Focus only on those 3. This technique comes from how large document research systems actually work at scale. Instead of retrieving everything every time, you retrieve by reference. It's the principle behind document management systems, and it works just as well in AI pipelines. The fourth strategy is grounding injection, where critical constraints from early stages are re-injected into later stages explicitly, rather than assumed to be visible. If Stage 1 established an important constraint, say, the analysis must focus on implications for small businesses, not enterprise companies, don't assume Stage 6 can still see that. By Stage 6, it might be deeply buried in accumulated context. Instead, include a brief constraint reminder block in Stage 6's prompt. Core constraint. This analysis is specifically for small businesses. Do not discuss enterprise applications. Re-injecting constraints isn't redundant, it's insurance. It costs almost nothing and prevents a significant class of late-stage failures where the model's output drifts away from the original intent of the pipeline. The fifth, most holistic strategy is what practitioners call the scratchpad model. Instead of treating the pipeline as a single, long, flowing context, you treat each stage as a fresh agent working from a clean brief. Each stage receives only a structured input prepared specifically for it. Origin context plus filtered output from the previous stage, nothing more. This is a design philosophy more than a technique. Never accumulate if you can scope. Design every stage to operate with the minimum possible preserved context, and trust that the I/O contracts between stages carry everything that's truly needed. Let's bring this together. The research and summarization pipeline is built on a 4-stage pattern: gather, filter, synthesize, format. Each stage has a distinct cognitive function, and trying to combine them into fewer stages degrades each function. The gather stage captures broadly. The filter stage curates deliberately. The synthesis stage constructs analysis, not just summaries, but reasoning across multiple inputs. The format stage translates that analysis into audience-appropriate communication. Getting consistent output formatting across pipeline stages requires specific, unambiguous format specifications, placed at the end of prompts, accompanied by negative constraints, and tested independently before the pipeline runs end to end. Don't optimize internal formats for human readability. Optimize them for reliability and parsability. And managing context accumulation, the gradual buildup of noise, redundancy, and old constraints across a long chain, requires deliberate design. Pass only what each stage needs. Compress intermediate outputs. Use indexed document references. Re-inject critical constraints explicitly rather than assuming they're still visible. And treat each stage as a focused agent working from a clean brief, not as the next step in a growing accumulation of everything that came before. Together, these three disciplines, the pipeline pattern, format consistency, and context management, give you a complete toolkit for building research pipelines that are not just functional, but robust. Pipelines that produce reliable outputs can be debugged efficiently when something breaks and can